Up to this point, to find the derivative, we have been using our limit as h approaches 0 of f of x plus h minus f of x all over h, definition of a derivative formula. Now we're going to look at some shortcuts that make finding a derivative a little bit less extensive. So let's see if we can figure out a few different rules and explore a few different shortcuts. So the first rule that we have is the derivative of a constant. And when we write the derivative, one way of writing the notation looks like d by dx. So this means the derivative of our function with respect to x. And if it's the derivative of a constant, we're just going to abbreviate a constant with the letter c right here. And that is going to equal 0. So what this is saying is the derivative of a constant equals 0. So if you have a function that is a constant, its derivative is going to be 0. So what does that look like? Well, right here we have the square root of 30. The square root of 30 is a number. It's just a constant. So that means if we want to find the derivative, so f prime of x is another notation for the derivative. So if we want to find the derivative, that means it's going to be 0 because the derivative of a constant is 0. Let's try the next one. We have the power rule. The power rule, again, we can say d by dx, just another way of notating that derivative, the derivative with respect to x of some function that has x raised to some power of n. And that's going to look like n times x to the n minus 1. So what this means is you bring down the power and you subtract 1 from the power. So let me show you what this means. Right here, we have w of r equals r to the 50. Well, w of r, so we want to find the derivative. So that would be w prime of r. This is some variable raised to a power. So our rule says you bring down that power, so that would be 50. Rewrite your variable, so that would be r. And then raise it to the n minus 1. So take your power and subtract 1. So 50 minus 1 is 49. Let's try again. Here we have h of v equals v to the third. So that means our derivative would look like h prime of v. Bring down our power. So that is going to be, well, notice right here it's a -3. So bring it down, -3 v. Now, if I have -3 and I subtract 1, that gives me -4. So -3 v to the -4. Let's try number 4. Number 4, we have y. So the derivative of y is y prime. And the rule says to bring down our power. Well, our power this time is -1/3. So -1/3 x, and we need to subtract 1. So we need -1/3 minus 1. Well, if we're in thirds, subtracting 1 would look like subtracting 3 over 3. So that means we would have -1 minus 3, which is -4. The denominator stays the same. So -4/3 would be our power. Let's try the next one, number 5. We have 1/2 t to the 6th minus 3t to the 4th plus t. So same thing, we're going to take our derivative of each piece individually. So look at 1/2 t to the 6th first. So our derivative will look like f prime of t. 6 times 1/2, bring down your power. We already have a 1/2 in the front. So when we bring down our power, it's going to look like 6 times the 1/2 because we already had the 1/2 there. So 6 times 1/2 will give us 3. T, and it was t to the 6th. So we subtract 1 and that will give us t to the 5th. Look at the next piece. We have 3 already. Our power is 4. So 4 times 3, when we bring down our power, 4 times 3 is 12. T, 4 minus 1 is 3. Now this one's a little bit tricky. Technically, it's t to the 1st. So if we bring down our power, that would be 1. And then if we subtract 1, it will be t to the 0. But anything to the 0 power is 1. Anything that's not 0, I should say, to the 0 power is 1. So this leaves us with 3t to the 5th minus 12t to the 3rd plus 1. So this is how we can use our power rule as we are working it down through. So let's look at the next one. For this one, we have a problem. We have two terms being multiplied together. That we'll learn how to work with directly later, but before we can find our derivative for this one, we need to clean that up. So let's FOIL it. So if we do x times 2x, and then x times 3, and then -2 times 2x, and then -2 times 3. So if we rewrite our equation, it'll look like h of x equals x times x gives us x squared. X times 3 gives us plus 3x. -2 times 2 gives us minus 4x. -2 times 3 gives us minus 6. So simplifying that, there we go. Excuse me. So we get x squared minus x minus 6. Now we can take our derivative. So if we bring down our power,